You know what? I'm going to go ahead and get started. So, welcome. My name is Dan Edelman. I'm the sales manager for TimberHP. This is the Beyond Our Value. Hey, Emily, how are you?
Hey, sorry.
Not a problem. Thank you for joining.
Just in
So first and foremost, thank you everybody out there for joining, listening in. These are going on YouTube as well after. So that's very exciting. We have a channel under Timber HP. Feel free to just follow right there. So again, my name's Dan Edelman, sales manager for Timber HP. I'm joined by some of other Timber HP folks. We have Bill Ryan. He's going to be in the background. Any kind of Q&A that goes in there, he'll be popping his face on here if there's anything that he wants to bring up in the time. If there's anything that can wait until the very end, he'll basically bring those up at the very end as well. So also joining me is Jason Todd, and I'm going to let him kind of do a quick introduction of him.
Hey everybody, welcome and thanks for joining us. We get to talk about a very interesting topic with some very interesting people. Director of Building Science and Industry Support, and very excited to be stumped by all the questions that come in.
Yes, roof assemblies are definitely one of the probably the second biggest question I get behind vapor barriers. So next I'm going to go down to Emily. Hello, Emily. Oh, you're on mute.
You'd think I'd know how to use Zoom by now. Hi, I'm Emily. For those of you who don't know me, I am an architect here in Maine, close by TimberHP. Super happy to support local companies. I'm also one of the co-authors of the Pretty Good House book, which might be where you have heard my name from. Or if you are super into building science, maybe you've joined us on the BS and Beer show a time or two over the last couple of years. So that's who I am.
Awesome. And welcome back, Emily. Always a pleasure to have you. Next, I'm going to go down to Chris Lawmore-Giddens. Chris?
Hey, Dan. Hello, everyone. I am, for those who don't know, I'm an architect, builder, consultant, HVAC designer. We get into building, designing, and consulting high-performance homes, from basic high performance up to passive house, and just trying to make buildings better and last a long time.
And you're coming from Atlanta, Georgia, and you could hear the sirens right behind you.
They're after me. They figured me out.
So yeah, one of the other things about this this webinar, this roundtable that we like to do is multi-climate. So we have Maine, we have Georgia, we have even Minnesota. So very cold climates and very warm climates. Next, Randy Rand.
Hey, yeah, I'm Randy Rand. I'm a builder up here in Orono, Maine, focused on high performance passive house. I'm also the training director for Passive House Maine. So we do a lot of education statewide on just meeting the state's energy code, which is soon to be the 2021 IECC. And so we have training statewide for any of that. So anybody here in Maine interested in learning more about that can definitely check out Passive House Maine for that, those details. So
Awesome.
But excited to talk about roofs.
Sounds good. And then last and definitely not least, we have Randy Williams.
Hi. Yeah, I'm the Minnesota guy. Climate zone 7, a little bit chilly. But right now it's 71 degrees and sunny, 50% humidity. I can't ask for any better weather. I'm a recovering general contractor who now writes. I have a blog. I'm actually in the latest edition of Fine Home Building magazine with an article on infrared cameras and that technology. And I also do some energy audits and consult with homeowners and builders on building better.
Awesome. Well, thank you for joining us once again, Randy.
Thanks for having me.
So today we're talking about building the best roof or roof, depending on what part of the country you're from. So first, because we do have a lot of new people on these webinars, I'm going to just kind of go through TimberHP, what we're all about first. Then we're going to be talking about thermal diffusion or thermal lag. This is something that I feel like doesn't get really much discussion points on. And on a roof assembly especially, I find that this is a very important part of that roof assembly with just storing heat. But we'll kind of talk about that in a little bit. Then we're going to be talking about the very controversial I'm sorry, that's not controversial, conditioned versus unconditioned attics. But we are going to be talking about vented and unvented attic design and kind of which one is the best roof and whatnot. But kind of going into the reasons of conditioning your attic space or not conditioning, and why would you want to and why would you not? And then some tips and tricks from the field that I've seen with, some hybrid systems, over roof systems. How are we building them? How are we even detailing a simple vented attic more efficiently? Some of those things are going to be in that section. And then final thoughts and any Q&A that kind of is at the end. We did actually receive a reply back from one of the webinar invites about venting a roof into a 2-story building, a shed roof, into basically a wall, and how that detail would look and how we would all kind of go against come up with that kind of solution. So we're going to go ahead and get started. TimberHP. So it is a wood-based product, hence the TimberHP. We like to say HP times 3 stands for high performance, healthy planet, and healthy people. Those are kind of the 3 pillars that we almost think of every single decision that we're making out there with one of these 3 in mind, whether it be high performance, healthy planet, or healthy people. I was just up in the great state of Maine. That's where our primary facility is right now. We're up on the Kennebec River. About 95% of our electricity consumption is actually hydroelectricity. So that's pretty cool. You can see kind of the production process there. We are offering some mill tours depending on when. Feel free just to respond if you're ever up in the state of Maine. We could put something together. Obviously, dates and all that stuff will come in mind. But if you are up in Madison, Maine, this facility was actually the UPM paper mill. So it was an old paper mill beginning in 1885, which is actually behind the mill that you see now. The current mill that you see now, that paper mill was 1985. So that was basically 100 years past, but it's really cool to get in here and just tour the facility as well and really see what we're doing and the energy efficiency, but with still having a very sustainable product out there. Some news out there. So this is some new fire and acoustic assemblies. We have a new ESL. This is something that now it's available on the ICCES website. So that's the International Code Council. And we have 1-hour and 2-hour fire rated wall assemblies, both wood stud and steel stud, and STC ratings of 50 or 53. So that's going to be industry leading as well. And that's really just from the sheer density of the product. And when we start talking about density of the material, that's kind of when I wanted to get us talking about, thermal diffusion, or, what really happens with different insulations on when they, probably protect heat. So I'm actually going to pass it over to Jason first to kind of get us started, and then we could have a nice little discussion on this as well. So Jason.
Yeah, sure. I mean, this is a great concept. It took me quite some time to kind of wrap my head around it. Didn't start out as an engineer, and math was not my forte, but definitely learned enough to be dangerous, as with most things. And one thing I've learned is that thermal lag, or heat delay, if you will, is something like Dan had suggested. We don't really talk about that much, but there's a combination of the characteristics of a material that we can look at going well beyond just R value, the steady state temperature. And one of the things that we found when we're testing our products, doing R value tests, we have to let them run a lot longer than other materials. It takes days actually to get to a steady state in our materials. And a part of that is this thermal lag. And you can see as we run the video, it's the density of a material the conductivity or the R value of the material, but also its capacity to absorb that heat, almost like a sponge. This doesn't get rid of what happens after we've gotten to a point where it's too hot in the building, but most areas, at least part of the season, have a natural swing in temperature throughout the day. So shoulder season or larger parts of the year, depending on geography. Wood fiber has the highest capacity for that heat to absorb it and hold it, even though it might not have as the highest R value of these three products. It will delay that heat longer to a point where cooler night air comes in and that heat flow can reverse a little bit because it's always high pressure to low pressure, hot to cold. So great stuff, and looking forward to really seeing this in the field as we get into the board production and get stuff on the outside of houses. I think it's going to be a great way for us to extend using bio-based materials, in particular wood fiber, and really extend the comfort in people's homes.
And then Chris, I know you have done a lot of research on thermal lag in general, and what have you found in, especially in a hot, humid environment like you live in?
It exists everywhere. That's the one thing. Jason, that was a really good explanation of it. The one way that I sort of use an analogy I use that helps a lot of people is coffee in a glass cup versus a ceramic cup. Ceramic has a higher thermal conductivity than glass does, but the the heat is held within the ceramic mug better than with glass, and that's why our coffee mugs are made of ceramic. So it's just it's finding that equilibrium is what, as you mentioned, there's high pressure, low pressure, and just naturally high is it's wanting to go to that low pressure, and as it's going to that equilibrium, it just takes a lot longer to get there in certain material, and that's where you might have a higher thermal conductivity in something or a lower conductivity in something else, but the heat might get to we might reach equilibrium sooner just because of that thermal diffusion, that thermal lag. And what's really important with the thermal lag, and then I'm done here, Dan, is like with heat loss and heat gain in a building, we make our buildings extremely tight. We insulate them well. Tightness is probably one of the key is probably one of the first key factors after water control. But when you heat inside or when you cool inside, you want to keep that you want to keep that conditioned air, the good air in and the bad air out. Air helps, but also so does these properties of thermal conductivity and thermal diffusion. So just think of it as it takes a really long time. If you have a perfectly airtight building, heat is still going to go through that assembly, but if it takes a lot longer to do so, you're better off. You're adding to that ability for the building to stay comfortable for longer. So just those are important. Just to surface, just on the surface, just tip of the iceberg of all the things that sort of it's not something we need to think about too much, but we understand it now, and there are many factors depending on where you are.
Yeah, and even when we started looking at names for this webinar, we came across beyond R value, and that's mostly talking just about this. Like, even though our R value is A, what's beyond R value? What's more ways of measuring, the high performance side of our HP times 3. So on that note, talking roof assemblies, and I kind of wanted to bring Emily in on these because I wanted to kind of understand which ones that she's familiar with or has used on her own projects, and maybe some discussion points on each one.
Happy to. Dan always brings me in because he loves when I say the people ask what they should use, what's the best solution, and I always say it depends. And if this wasn't a 1 o'clock webinar for those of us on the East Coast, you'd all have to drink right now. So I know there's at least a couple BS and beer people in the audience. I keep seeing your name pop up, but we in our office have been a little bit not excited about foam above grade for many years. We use a lot of fluffy insulation. We use a lot of cellulose in the Northeast. And so I think I have done all but the unvented exterior that you have in the top left corner, assuming that your unvented exterior is not some kind of foam product. So assuming because it's colored in TimberHP that it would be TimberHP. And so we have not done a fluffy unvented roof structure just because it's a little riskier than I would prefer to do. I think Stebrick and Building Science Corporation have done a number of tests on this, and if we had our fellow BSer Ben Bogie on here, he probably has also done some of his own testing on that. There was a question somewhere in the chat too. The biggest failure on that is usually at the ridge, right? That's where the solar vapor drive sort of ping pongs that moisture all the way up through that fluffy, or well, not fluffy, the porous insulation, and that's where your water gathers. And so I just tend to do a little extra CYA in our area, which is to vent it. We will probably always vent it unless we can't do it otherwise. And the interior plus exterior version in my world probably would also have some kind of foam and maybe a timber bat on the inside versus unventing it. So the middle of the top over vented exterior and the bottom flat attic and vented are the two most common that we do here in this market, because they add a layer of safety that makes me feel a little bit more comfortable. However, there's lots of coastal water and rain upside down and fire-prone areas in the country where you want non-vented assemblies, which kind of makes sense. So what's the best roof? That really depends on where you're at, what you have, what you're left with, if it's a renovation, right? So we do a lot of the over insulation if we're working on an existing house and we need to add it. Although I'll let Jason weigh in on how much it weighs, because that's something else that was a conversation that we had, I don't know, a week or two ago about the weight and wanting to add it to a structure and making sure that if I'm gonna do that, I have enough structural integrity to add weight to it. So there are so many things that come into play or that are factored in the way that you do your structure. And I 100% agree with Chris, is that air and water first, and then take a look at what you can do for your insulation within those, because it's all part of a system, and you can really make some other part of your system vulnerable if you don't know what all the other parts are doing. So how's that for a long-winded answer to your which one is the right way to do it?
Perfect. And actually, I did want to add also, and 100% correct, and I'm very much on board with the venting all assemblies, because I feel like for myself included, it's more of like a release valve. It's like, a release valve on your water heater. You're not going to not have one, because if there is an issue or extreme something happening, you need somewhere for that pressure to go. Now with the unvented that we do have here, you're essentially creating, it needs to make sure that you're vapor impermeable on that top layer. So you're almost making a foam board on top, because this is all vapor permeable. Timber board will be vapor permeable. So you do need like an ice and water shield underneath, ice and water shield on top, and really just sandwich it so there is zero permeance of that entire assembly. Where the vented ones, those you could use WRBs, you could let that vapor just move right through that system, ping pong moisture right up to the ridge and basically just have a nice escape valve for that, for all that vapor. And that goes for the unvented exterior and the unvented interior and exterior. And simply venting is just, what are we using for venting? And I'll actually pass it over to Randy Rand. Like, what are good materials that you use to vent a roof? You're on mute.
Yeah. So I like to make sure that our vents aren't susceptible to damage, because we see that a lot up here in Maine. A lot of attics. Over the years, people make modifications in their attics. They're in and out of their attics. They're running vents. So the majority of the time I am using plywood as a baffle or something more rigid, rather than like the foam inserts and those type of things. So I do spend a little bit more money and a little bit more attention to detail as particularly in our blanket attics, how we're detailing that out to make sure that, it's gonna stay, it's not gonna disappear. And we always will have that continuous flow. So.
And then how about you, Randy Williams? What kind of vents are you seeing out there, whether it be an over roof system or conventional attic, vented attic? You're on mute too.
Sorry.
Randy thing.
So in my market, I mean, the most common roof is going to be just the flat ceiling vented type. That's the easiest thing for anybody to build. It's the most durable, at least in my area. The problems that I see are with trying to make an unvented roof assembly, especially using like a closed cell spray foam on the bottom side of the roof sheathing. That's obviously not vented, so that becomes a problem, because often I see air movement through there. The trusses, either the foam is separating, or the trusses are mated together and there's a gap right there, and nobody thought of, well, we should probably seal that off. We got air moving up to the roof sheathing. It was in one last winter where we pulled some of the roof off and it was all wet. The roof sheet, this is a 1-year-old house, that the roof sheeting is already all wet, closed cell spray foam, all air leaks. In that case, that should have been vented at some point, probably above the roof line, or even better, add the insulation above the roof line, above the roof sheathing, and make that whole assembly warm. Would have been a better one. But like I said, the most common is that the soffit to ridge vent on a flat ceiling. Bulletproof, we can, at least in the stuff that I'm involved with, we can make that ceiling airtight, so we don't have that moisture moving up through there. The vent is just really to keep the roof sheathing a little bit cooler. Hopefully we're not getting some snow melt where we'll get ice dams, issues like that. So yeah.
Awesome.
Hey, Dan.
And I do have your images from the building science investigation on those truss assemblies back
Awesome.
on this presentation. So
okay, cool.
We'll show those too. And then Chris from the South, because I know, and if you want to talk about like climate zones 1 through 3, because that's kind of where that differentiation is. Which roof of these do you like, and why would it work more in a southern build? And what is your favorite one also?
Well, first of all, I don't know. The Randys have a mute thing in common, and Emily and I have a it depends thing in common. I have been giving that answer to everyone has ever asked any question for anything from construction to design to HVAC, whatever. And it does. It just depends. I mean, there's budget. There's preferences and how sick people are or are not. But anyway, so any assembly that we're trying to, so we have over the years have gotten away from, we tell our crews and all the people that we work with that foam is a 4-letter word and an F word. So it's not to be used on our jobs. And so, and that came from a lot of bad experience with clients collapsing and systems having to be replaced from the chemicals and all sorts of things. But there's just a better way to do it. There's other material that can do it. It's not about necessarily the chemicals as much as they're better performers and they're more durable, more robust, and can do the job. We don't need to rely on these products that are simple or the foams that are being used. But we have volume concerns. So the fluffy attic floor is something we do. We put that air barrier to the top of the ceiling joists, and then we fill it up with the fluffy stuff and give it good ventilation. And it's one of the most efficient ways that we design. Our woofy models show it saves a bunch of energy by bringing the volume down and putting a little big fat layer of insulation there. We also do continuous to the exterior, just thermal bridging. Here in the South, if we have 1.5 inches of continuous insulation, we're in good shape. Pretty much anything beyond that's going to give us a good reading on our condensation risk. The condensation's where we want it to be. But you can't, there are limits to that. You can't just keep adding to the interior because that can move that moisture risk line to the wrong spot. So you have to be careful about that as well. So there's no like silver bullet or rule of thumb that you could just go with, period, and stop there. So we like them all because they all have their appropriate application. We tend to aim for the vented attic because of the simplicity of the volume. But depending on where the mechanical systems have to go, we're not going to put them up in that attic. We're not going to create a room up in the attic for it. We're gonna, if it has to be up there, we have to go to a ridge line. We have to get that all within the envelope and then pay that energy penalty and make it up somewhere else. But we like them all, and it's just, we make them work. We're just using the science and the design.
And just a reminder of the diverse geography that we've got on the call and also with those assemblies.
Mhm.
Some of those are going to fare better in some areas than others, and to Emily's point, we might not see as many of those unvented sloped roofs in the Northeast, and part of that has to do with even snow load gets into it and how much moisture is going to sit on the roof over time. We touch on that a little bit in the builder's guide, and certainly deeper dive in some of Building Science Corp's work, but just wanted to bring that to everyone's attention, or as a reminder.
Yeah, 100%. And yeah, that's always obviously referred to a professional when designing a roof assembly, whether it be us at TimberHP or one of the architects that are online, or a local, or the builders that are also available to you. Chris kind of alluded to this one, but why would you have an unconditioned attic? He kind of brought up mechanicals and mechanical systems, and why is that a bad idea to have mechanical systems or vents up in an unconditioned attic? I'll go to Randy Williams.
Well, my climate, they get cold. You got vents, ductwork, that kind of equipment up there. If you throw an HRV in an unvented space in my climate, it's not going to work. They don't operate correctly below 55 or 60 degrees. At 20 below, they're not working at all. They're all froze up. So, yeah, that sweating, the condensation. I'm sure Chris sees that all the time with his, air conditioning. The ducts being cold and dumping into a hot spot with the sweating up in the attic. We get the same thing. It's just ours is in the wintertime when we get a little bit of condensation inside the ducts and it wants to dribble out, even if they are completely encased or insulated like they should be. Better off not putting them up there. Leave them in the conditioned space. It's way better off.
I would add to that too, aside from just having the mechanicals up there and then their performance issues with them being either in a really hot space. I'm sure Chris is going to say the opposite for the really hot space. You're asking it to work way harder. And Randy's really cold spaces, the more holes you put in your air barrier of your ceiling surface, which in this case is your ceiling surface, the more you're going to create other issues, right? So, you know, you want to try to transition between the conditioned space and the unconditioned space as infrequently as possible. There's going to be things you have to put through there. You know, in our market, a radon vent, like, sorry, it's got to go through that. But, you know, ductwork with a good design should not need to go in there. And building science will tell you, you know, which parts of your houses should be all inside or all outside. And so you don't want to put anything mechanical, water related, you know, even light fixtures, you know, into the space between the two.
I like to use another analogy for this. It's like your body is also a system, just like your mechanicals are a system. And when you're in a cold attic, you tend to slow down. When you're in a really hot attic, you tend to slow down and work. And it takes a lot more effort for you to do the job in a hot attic or a cold attic because you're having to fight, your body's having to fight that temperature loss or temperature gain. So it's working harder to actually work, and the systems that you have up there are exactly the same thing. Your fingers, your extremities, just the ductwork, same thing. All of that starts to break down and starts to weaken as the longer you're up in there. And so aside from all the, you know, obvious stuff, the condensation, the you know, just everything not working, for example, the ERVs, it's just, if you think of it that way, is don't do anything, don't put anything in the attic that you wouldn't, if you know, that if you wouldn't want to be up there, don't put your systems up there either. But
And I'd even add, for why have an unconditioned, is definitely cost. I feel like this is a very cost effective way of getting a higher R value or high insulation value too. With a pretty simple detail. Now, recessed lights, I think, is probably one of the biggest air infiltrations, or areas for air infiltration in an attic, but also top of walls, you know, top plates, all that kind of stuff. But as long as we detail that properly, and you can kind of see that picture on the bottom right where that blue, or I think it's the red line. Yeah, so that's the interior vapor control, basically connecting to the ceiling air barrier or vapor control. But you could also bring that from the sheathing in as well. So wherever that lines up, whatever your primary air barrier is, it's still continuous across that ceiling plane. And I think that's one of the biggest things. Obviously, you still have electrical things, but there's definitely, you know, caulks and sealants and tapes and everything else that you could really help with the air tightness of that lid. I did want to do a quick.
Oh, go ahead.
Go ahead.
I was just going to say I sort of mentioned it a few minutes ago, but there is a strategy that I'm seeing more and more people do. I wrote there's an article that I wrote for, if you look up an airtight lid done the right way or something like that in JLC, it's this idea of moving the air barrier to the top of your ceiling joists, and then everything below that then becomes, you don't even need airtight cans. You can just run all of your systems and mechanicals in that cavity space, and you can still have a continuous, all your control layers stay continuous, and you get that really thick layer of fluffy stuff. And your framers love stick framing the roof because they have a platform that you've created for them. So there's so many things about that, but that's one way to do it. If you want to look, anyway, it's out there. A lot of people are doing it now.
Yeah, and I think I have that detail. Was that JLC? They wrote that article?
Yes.
And then why have a conditioned space? I think we just kind of answered the same question by saying why have an unconditioned space, but why have a conditioned space up there?
a place to
that
put
stuff
all
right
attic.
there.
Yep, yep.
Yeah.
Put it
Yeah,
all, keep it all inside. Yep.
yeah.
Yeah.
So we just one of my customers out here in Pennsylvania just conditioned their attic uh in a 300-year-old house, which was pretty neat. So you didn't have much room up there, but all that they wanted the attic space for was to actually keep their Nike collection or their shoe collection up in the attic. So you definitely don't want to keep any collections or even one of our other people that used our product and we did a conditioned attic for was Mike Richter, and he had to make sure that he had all of his hockey sticks and pads and everything in a nice conditioned space. So so that
And
was
if
pretty
you
cool.
if you live in a climate where basements aren't common, like climate zones 1 through 3, and you need a man cave, it's perfect up there.
Yeah, there you go.
Yeah.
I was involved in past lives with a lot of retrofit and retrofit training on a national scale, and it was always interesting to see by geography. And you're down in Texas, and that top left photo is perfect because big, tall, strangely tall attic spaces. Like you could put a whole other house in that space often. And they'd been them, but I'm not sure it was the best, but mechanicals were often up there. Now you still should take care of your duct work. You still should be sealing that stuff, but it's less of an impact. It's that, the performance of the thing, whether it's a person crawling around up there or a mechanical system, as Chris was talking about. I think it's great. And in retrofit work, crawling around in that, what I used to describe yoga in hell attic, where you're trying to get into the tiniest little corners and do some good solid air sealing that you don't have to go back for later on. Quality work. John Tooley always talked about quality work. Um, Veteran in the industry and trainer as well, and the importance of doing the right thing when no one's looking. And I'm guaranteeing you, no one's going to go and check that work back there. But if you can switch that attic around and make it a conditioned attic in a retrofit situation, it's oftentimes a lot better. Just better performing house, reduction of many of the other durability issues too. Always climate dependent, always house dependent for sure.
Another thing to keep in mind with this attic thing, I think is important because of, with mechanical systems and energy, we're trying to save energy and save costs and things, that we can't ignore the volume that this adds to the structure. So we have to consider that. We're working on a house now that I calculate the load for that attic. It's not necessarily a part of the main system, but it can add up to a ton of cooling or heating load to the project. Or more, depends on the house size and the attic size and the peak and everything else. But you've got to factor that in and you've got to account for it. So it's not just raise it up, keep the same system size and just put it upstairs. There's so many things that affect the performance of the system and the performance of the home. So just don't ignore that among all the other things you're not to ignore.
In another little another part of that is also keeping this area connected to your house or making sure that there's some sort of vent in there. Now I remember Joe Stiebrick down at an event that I went to in Florida. He was talking about putting louvers in the closets, because in closet spaces in Florida, they get very moldy in there because you're not going to put a vent in a closet. But if you're conditioning your attic, now you could have a vent inside of your closet that's connected to your attic, and then you don't need to do the louver doors on your closet doors. So that I thought was actually pretty interesting because now you don't have the louver doors on your closets.
You're talking about for return pathway?
Yeah.
If your jurisdiction allows you to do that, sometimes they won't let you use your attic as the attic plenum. So it's just a matter of location and who's looking at it. But we've run into that many times because we've done that strategy.
Yeah.
But we've also connected the room where the heat pump water heater is we do the same idea where we connect it to the attic because the heat pump water heater needs volume because it's got a heat pump on it. But because it offers that drying of air, it does do some dehumidification. By connecting it to the attic, it contributes to keeping the attic dry without having the dehumidifier do some of that work. So we do that sort of connection there, and there's no code violation with that. That's just a huge benefit for it by not putting the water heater up there and worrying about it leaking into your home, but still taking advantage of that heat pump, the dehumidification of the heat pump.
And then, Chris, you're then bringing your thermal and air tightness down around the
Correct.
space you're storing that water heater.
Well, if the attic is already, if we're sealing it at the, I mean,
Right.
if the roof line is insulated and sealed, yeah, that's,
Gotcha,
we don't do that to an unvented or to a vented attic. It's only when the attic is part of the thermal enclosure. Yeah.
Well, Dan, I know we're close to 15 minutes here till 2 o'clock. I know you mentioned the vented over roof question at the start, but we also have some questions in the chat. So I'll let you kind of let me know what you want to start with, but I know people are firing away in the chat.
Oh yeah. Yeah. If there's any questions on these two things, I know we're going to be talking more about vapor diffusion ports next, but if there's any questions, definitely let me know what they are.
Not on this particular topic. Lots of questions on venting over roof and that sort of
We're
thing.
gonna,
So
yeah, we're gonna be getting to that actually right now. So
okay, I'll hang tight then.
yeah, so vapor diffusion ports, this is something definitely climate zone 1 and 2 is what we're kind of talking about, but you could also do it in climate zone 3. In our builder's guide, it kind of tells you how to build not how to build them, but basically what that looks like. It's simply a release valve at the top of your roof for the warmer climates. I don't know if anybody wanted to bring up anything special notes on these vapor diffusion ports, but you can in fact have your insulation up against the roof sheathing and you can kind of see that ping pong moisture kind of going up in the top right detail there. And it's still allowing that to vent properly with vapor permeable insulation.
Oh, go ahead.
No, go ahead. I was gonna, if there's a question that popped up alongside, but you go ahead, Chris.
I would just add to this that if this is showing a hip roof, and when you have conditions sometimes where you might have a shed roof or a dormer or something that the insulation runs to the walls, and you need to also consider the movement of air going sideways when you're considering this vapor diffusion. So it's not as simple as just put it at the ridge, and only if you have a ridge do you need this. You have to think about just this happens no matter what. If there's a dam somewhere for that vapor to hit, we have to make sure that we think about how that vapor can evacuate sideways or vertical. So anyway, that's all. That's the only kind of a critical thing there, and just know what you're doing. And also climate zone 4, there are some cases, Joe did mention a few cases in climate zone 4, Building Science Corp did, and they're not enough there to say that's why it's not in the code for climate zone 4, but there are some cases there. So we've designed it into our projects in climate zone 4, just whenever we get into these situations, just because it doesn't hurt.
Yeah, I think it's an application, particularly with our product, that would work in climate zone 4. We can take on a lot of moisture with the very, very vapor open cavity insulations and the board insulation. They are treated lightly in order to protect from any kind of biological growth. But the advantage of you can imagine we've kind of reconfigured a tree in a sense, and that's how all that groundwater gets to the leaves. It's that capillary action and movement through the cellulosic fiber, the cells that carry that moisture, and we're looking at that buoyancy, whether it's a ridge or the termination of a hip roof. It's going to find its way upwards. Once we get past climate zone 4 and to 5, then we're starting to talk a little bit more about snow loads and the influence on a pile of moisture sitting on top of that roof potentially, and the risks, and the fact that we're most likely going to seal that roof more often than not, or completely ventilate it. So a diffusion port typically at that point might just be closed off. Little side, I noticed one of the questions is talking about a WUI compliant diffusion port, and it's paperless gypsum as your diffusion at the peak, and the tightness of that ventilation space would allow for that. I think it's just making sure that it's protected, that you could not get embers within beyond the fire resistive cladding, roof, shingle, metal, whatever that might be. So yes.
Awesome. And then conditioned attic systems. So just wanted to talk a little bit more about through some of these designs. This is all these details are in the guide for builders, and with write-ups about why and how to look at these as well. But it sounds like, you know, just looking at kind of, I'm going to look at that top right one, you know, with the vent, with the hybrid assembly. You know, what are some big things for that when you're looking at climate zone specific details? The thickness of the insulations or whatnot.
Got to check your woofy.
Yeah, I was gonna say you gotta check your hydrothermal model.
Yeah.
I mean, and I would say code worst case scenario, the IRC does give you some guidance for some standard things. Again, it depends on the materials you're using, because the code can't tell you specifically what material, and it depends on what, you know, 4 is drastically different than 8 in the amount that is over top of it, and what you're potentially trying to keep dry, right? So in the top right, since that's the one you brought up, Dan, your sheathing's kind of in the middle there. And so your sheathing, you know, in the code, I think it's going to be closer to like 50%. It's definitely much more on roofs than it is on walls. And I don't throw out that 50% as a rule of thumb. Don't follow that. Please do please do your research on it, but it does depend how much insulation is above and below. I liked how Chris kind of said it as a throttle. Find out where your vapor throttle is for sure, and whether or not for our climate zone, if you can keep it warm, it's less likely to get condensation on it. And how you vent over top of it can get complicated when you're adding a lot of exterior insulation, because the other thing that we only briefly touched on, you touched on cost, Dan, is great in theory, not always in practice or installation. So also think about how the people in the field have to physically install it. I'm sure both Randys can attest to, you know, having to try to take a detail and then physically make it work on site is always a challenge. So please also, when you're designing something and thinking about this, keep in mind how someone is physically going to make it work. Once you understand all the science behind it, it still has to be buildable and hopefully cost effective-ish.
Mm-hmm.
Looking like a true architect.
It depends
Yeah,
an ish.
good one.
It
We talked-
depends. Ish.
Yeah.
The roof. I'd rather see you spend more money on your roof than your walls, right? So I say ish. Like
Yeah.
I really like cost. It depends on which part we're talking about. You know, I'd rather see you spend a lot more money on your roof assembly than on your kitchen. Just saying.
Right.
We talk, Emily, we talk more about value than cost, right? It's more
Exactly.
about
Yeah.
Value. You want to be comfortable. How do you want to feel in your
what
space?
what do you value? You know, she mentioned the ratios in the code, and the good thing about those ratios are that they've come from Joe himself. I mean, those are based on the research that Building Science Corp has done, so we can rely on those ratios for the most part. And it is something that every scenario, no matter what, we still do our hygrothermic analyses on all of our assemblies. And we, of course, in a certain climate zone, you might do the same assembly over and over again. And so each house, the variables are air sealing, the people, the kind of the lifestyle, the orientation. So it's still valuable to check your hygrothermics, but there is a starting point in the code. And if you follow that, at least you've met the code. It's not going to be perfect exactly, maybe not, but it is in there for both wall and roof assemblies, and it's a really good starting point.
That came up on a past conversation, and I think Randy probably have something to say about it too, but it was the 2018 code cycle that the ratios were right. And they didn't list it as a ratio per se, but they said a certain amount needed to be above. And then you had to meet your thermal amounts as a total. When we moved to 21, they upped it for us here in the colder climates in particular, maybe more down towards you as well, Chris, I'm not sure, but the ratios were no longer right. So it's somewhere around 30% for marine, and then 40% for 5, and on and up.
My rule of thumb has always been 10% less than your climate zone, add a 0 and drop 10%. And that's typically what it is. Climate zone 8, it's going to be a 70% on top of for the total R value. And I would also put in there aged R value, because I find a lot of foams out there are going to age and the R value is going to change. So day one, yeah, it might be the right ratio, but that's where having products that don't off gas and lose R value over time are definitely a benefit to that assembly as well.
And the air sealing could change as well over time.
Yeah.
So that changes all of that. So yeah, so much.
Yeah.
I know that Joe Streberg's planning on updating some of the documentation on his side. I know he pushed for a ratio in the code. And Randy, do you know anything about the 24 cycle and where we're at with the insulation requirements or ratios at that point?
I haven't dug into it yet. I heard that they had dropped a little bit. For instance, the R60 that's mandated in for just regular attic insulation, I think dropped back down to R49, I believe. But again, I haven't dug into it for sure yet. Yeah.
Everything to the outside, always 50 inches minimum.
50 inches, how much would that weigh, Jason? 50 inches.
We never did talk about the weight. We never did talk about the weight. Just generally speaking, we can produce a range of board weights, if you will, and that affects our value, and it affects compressibility. And we're going to have a middle of the road, probably, let's say 9 pounds per cubic foot. If you have a 5.5 inch 4x8 sheet, that's 140, 150 pounds.
Ooh,
but it gets a little heavy. That's not a carry it up a ladder by yourself board.
No, definitely not. So I did want to kind of go over an actual project. Chris Lamore Giddens down in Marietta did an overroof, and kind of wanted to talk about the detailing, because a lot of these, when you're talking, if you're a build show person, monopoly framing is a term that Matt uses often, but really just having that air barrier continuous with the thermal barrier. And Chris, how did you construct your, outriggers or overhangs or whatever that might be?
Yeah, this was done in 2017, I believe. This is everything to the outside. And we just, conceptually, you look at the shell of the building as just completely continuous. We used a liquid applied membrane around the structure and none of the overhangs. So this is how you do an overhang without having it penetrate the building envelope and then do all continuous. And so we did we got a 0.05 ACH50 on the shell with this one, using the liquid applied, very few penetrations. And then we built these outriggers that you can see sort of from the pictures, that you have a third of the outrigger over as an overhang, and then 2/3 of it is attached to the roof. And then you can see the clips that we're using. Those clips go directly into the framing below. And then of course, the screws are gonna, you think, oh, that's a hole. Well, those are pretty tight in there, and they're not really creating any air leakage. We had about 5,000, 6,000 screws in this building envelope when we tested it at 0.05 ACH50. Those screws were what were holding all the insulation to the building. And so you build these outriggers, and you space the framing so they're perfectly sized to the board, the insulation board that you have, both the length and the width of them. So they're make it easy for the installers to just cut it to length if need be. But in most cases, they're exactly the size of a board. And then you just infill. So this is the first layer. So 2 layers of 3.5 inch, the depth of the 2x4, and then on top of that was another 3.5 inch layer over a peel and stick membrane on top of our sheathing that did connect with the liquid applied membrane over where the wall met the roof. So we've done this several times, and it's just the same. You've seen this, starting to see it more with Matt starting to talk about it. It's becoming a thing. How do you get an overhang and still make it look like it's coming through the building like most houses are, and then not have any penetrations whatsoever? So this worked well. The framers picked up on it real quick, and it's not the cheapest thing to do, but it certainly is achieves what we needed.
Yeah, I'd also add, I was just over at Randy Rand's house. He has 8 inches of continuous on top of his roof. And what's nice also about the outriggers is a lot of people are concerned about the thickness of their soffits. And, you're not going to have a 14-inch soffit. It just doesn't look great on the house. But with this kind of system, now your soffit or your reveal or whatever you want to call it, your fascia board, is, a 2x6, a 2x4, whatever that might be.
Yeah. And speaking of we actually went with the full thickness, so the 7 inches all the way. And we extended the insulation to the fascia because we wanted to encapsulate all the framing. And we're not talking about 4 or 5 feet, and it did add cost, extra insulation, but it kept the framing all at the same temperature so that we didn't have expansion contraction outside, and any kind of warping or anything that would happen beyond the envelope. So it was part of that, and that's what you see in the upper right. You can see that the insulation extended all the way to the fascia, and we created a way to support it underneath, and then that way everything's the same temperature. It's all part of the enclosure.
Awesome. And then I know we're just at the hour. Emily, I know you have to jump off.
Yeah, I was going to say, it was great to see everybody. This is a great webinar. Yeah. I love what you did here. I'm going to be late for my next meeting if I don't hop off right into. So great questions. Everybody on the webinar knows how to get a hold of me. So if there are people in the chat that have questions, they'll figure out how to get you to me. So have a great day.
That works. Thank you, Emily.
See you, Emily.
And then we do have the building science investigations with Randy Williams. Randy actually has a great blog. I don't know, Randy, if you northernbuilt.pro, if you go there, but he did one, and I have the hyperlink on here. Construction design problems with attic trusses. And Randy, I just didn't know if you wanted to walk us through what you saw here.
Yeah, I can do that. So these are 2 different houses. The 2 roof pictures. One, they're both new. The center one was an unoccupied spec build, and the one on the left was a new custom home built. They both featured room over attic trusses. So you had a living space. The one in the middle was over a garage space. The one on the left was actually a slab on grade house where they built the that's the picture of the trusses right there. That's very common in my market. Slab on grade houses that want to have a second story, that's what they'll go with to keep the height of the structure down a little bit. Interior, that's what the interior looks like on a lot of those. The issue gets to be is that how do you insulate that? In my market, what they're doing is closed cell spray foam at the roof deck. Sometimes they're adding an airspace, sometimes they're not. There's a video of a failure. This wasn't one of these projects, but I see that quite often too. But the picture on the left there is actually the roof that we took apart. You can see a few drops of so I discovered that one through a blower door test. It was in another attic over truss where it had separated. Don't know why it separated. It just did. That ends up being
Because it's foam.
that ends up being a massive air leak where it ends up heating the roof up. Dan, can you go back to the thermal images?
Yes.
That's what I see. What those look like. The thermal image on the right there. That's what I see when that happens with a blower door test and thermal imaging in my climate is a big air leakage issue, and that's going right to the roof sheathing. And the picture on the right there where it's melted more, the center picture where it's melted more on the right side of the roof, that's that location in that thermal image where we had a higher heat loss that's melting more of the frost off the roof. Again, getting back to how they were doing these, they were closed cell spray foaming. A lot of times what happens is these are trusses that sometimes they need to mate 2 or 3 of them together to for some kind of a load, a bearing point. And nobody thought about sealing that up. Those gang plates on the trusses sometimes will leave that gap, just like that one. We've got a a 1/4 inch gap that goes from all the way through the truss. It leaks air like crazy up there, and that's what we were seeing was that interior conditioned air coming onto the surface of the wall, the roof sheathing, and it was condensing right there. There's one of the pictures of the 2 trusses mated together. You can see the gang plate that'll separate that a little bit. They tried to fix this roof by doing what they did, this closed cell spray foam the 2 trusses together. The problem is that leakage point's on the bottom. It's on the outside, where the tails hang off. It's all over the place, and it'll pull the air. It'll find a pathway to get up to the roof sheathing where it'll condense. Probably the best thing that there's a picture of the what it looks like in those attic spaces. They're inside the house, but they're just leakers. Right there is what we should be doing. Doing the attic over. We can vent it. We could do it as on a conditioned roof without a vent if you wanted. I'd prefer to see the venting to try to keep the roof sheathing a little bit cooler, eliminate a little bit of the ice damming if possible. Yeah, I think that's the only solution that I could see that would be foolproof, that would work every time.
A lot of challenges in air sealing those, even just in general. We use them a lot over garages, and and then those garages are open into the rest of the, they are a real complication on many fronts.
Yeah. That house that where we pulled part of the roof off that was wet, that tested the blower door test was less than 1 ACH 50, 0.97 ACH 50. It's tight, but it's where the air leaks were occurring that were the issue.
This is pretty common, and a lot of builders, at least here in the Southeast, we see a lot of them always including interior air sealing in their budgets, and it's just with their budgets that they have, it's just as easy to include doing it all from the outside. And what happens when you go to the inside is you can't think about these every single one of it, just like you're showing there, Randy. It's hard to think that through from the inside, whereas from the outside you're just it's just like a simple layer out there. The complexity is less out on the exterior, and it's why most people are pushing for let's get our exterior air sealing. That's really and all your control layers to the outside, and then let everything in the inside be full of gaps and cracks and whatever. That's fine.
Yeah. And if possible, simplify, especially the
Yes.
roofs.
Yes.
That is the hardest thing to do, is get an airtight enclosure, or even some of the insulating details when there are roof pitch changes and direction changes and dormers all over the place. They're just, it's complicated. Yeah.
Yeah.
Awesome. Well, thank you, Randy. And I understand with the time, during the middle of the day, it's a little more challenging for everybody to stick around for extra 15 minutes than when we have these at 4 p.m. I did want to just, briefly, and I'll just kind of run through these because these were some pictures I took. Simple tips and tricks. There's an energy heel for a vented attic. That was actually my house in the middle there. So we just simply added an additional 2x10, so we could add another R38 in that same space without it blocking the vents or anything. And then the WRB, or what I did was, and I pulled this from Randy Williams' playbook, but basically putting the tape or WRB over the top plate before you put your roof trusses on, and that just kind of continues your exterior air barrier right across your ceiling. So I think that was really beneficial. And then the one that I always find is really cool is the plenum truss. And if you are needing to run mechanicals up in an attic, you could also do the plenum truss, which is what Randy did up in a house that I've visited, and you could kind of see how he air detailed that. And then all the mechanicals, all the ducts and everything went through that space on the far right here. I did want to get to one Q&A that we did have that was but basically this is the house. This is the detail. How would you vent an over roof system with this detail? And I'm going to go to anybody that wants to answer. I've done this in the past, and I've had it so it was integrated into the wall rain screen.
Wait,
so
what do
it
you
basically died into the wall rain screen, went back up, and then it went through the wall rain screen vent.
I missed the question. Sorry.
So it's a vented attic system where the top, the ridge part of the mono pitch slope roof ends at a wall. How do you continue that ventilation through?
With like an over roof system. Yeah, so a hybrid roof design with continuous insulation on top. And then how do you vent it basically at the top of the roof without having a leakage point right in that corner?
And using steel as the roof finish. Yeah, that shingles are a little easier.
I have a detail. I can pull it up. I've done it, well, like some other time, but it is, we have our ventilation system on the wall. We have a rain screen, and then we have, of course, the ventilation on top of the over roof insulation, and they are connected. And there is flashing that covers where the roofing hits the wall, and underneath that flashing is where that air can go up and follow that rain screen. And then at the top of the rain screen, of course, is a gap.
And even if it dead ended into a wall that didn't have that, you could have a return essentially with enough flashing over the top of a plasticky product that would fit in that space. So you'd have something that could vent but still be protected, I imagine.
And let's not forget also the sideways. We've done the house that I was showing earlier. We had the 45, the 1x4s were at a 45-degree angle to the structure of the roof. And we had a core vent running all the way at the perimeter so that ventilation could happen in all directions. So that's another way for that air to go. And then that's connected to another piece of core vent in the fascia that can sort of horizontally, but it's going in all directions.
I think that for this, the view that I see, I think the diagonal burring or
Right,
2
get it over
4s
to the
for an inch
side,
and a
yeah.
half
Right.
space
Yeah.
would be, because then you're
Right.
venting around the
Yeah.
all, yeah.
And you might split it, you might go in both 45-degree angle, different directions. So
Oh, you could do it in
you don't
like this
concentrate.
logo.
There you
right
go.
here.
The,
That would work perfect as a rain screen.
Farmer
That
Gibbons
was-
herringbone ventilation system. I think
That
staggering
was-
your strapping too could work, although it's a
Yeah,
little complicated either way. It's not,
Yeah.
doesn't have to be pretty, like Chris would make it with a herringbone, but
Hey,
Yeah.
everything is architecture, man. Everything is.
And one thing too, when you're doing these long, like let's say we're going diagonal, you could leave gaps between them and you could get some,
Even
every
more.
channel doesn't
Mhm.
need to be, they could be connected to each other. It doesn't need to be like a long channel, like airflow is airflow, and getting between there, like below window rain screen detail, sorry, the tangent, I never will run that rain screen right up against the bottom of that window. I'll actually leave it like 2 inches, so then it kind of goes up and up around the side.
hey, Dan, we're
Yep.
10-12 minutes over. I do need to hop. I don't know about the rest of you folks. Don't want to run, but I'm gonna let you handle it from here. And thanks everyone
Right.
for jumping on.
Thank you, Jason.
See you, Jason.
Take care.
And end of the day
Mhm.
is much better for these. No, so I just wanted to kind of do the final wrap up. I also need to jump on the road, but thank you all for joining us. I did want to kind of like, where do I find you, Randy, and Chris? Start with you, Randy Williams.
You can find me on Instagram. I'm Northern Build Pro, or on my website at the www.northernbuilt.pro.
And then Randy Rand.
Yeah, so you can find me at r.hoss on Instagram. We've got some roof details coming up this week that'll be kind of interesting, so that'll be cool. But you can also find out more about trainings and different events that Passive House Maine's doing at passivehousemane.org.
And then Chris.
Right now, you can find me in Atlanta. Next week, you'll find me in France. No, but LG, our Instagram there. We have a YouTube channel, LG Squared, and lgsquaredinc.com.
Awesome. Well, thank you guys for joining once again. By next month, I'll have a beard. Probably not. My wife won't allow that. And as long as we have Emily on, I'm safe. I don't need to go with the beard. So, yeah, thank you everybody out there for joining. I think it was another great roundtable, and yeah, catch me. You could find me, just simply reply back to the emails that you've been getting for the webinar, and we could go through any project details and dealer locators, any of that support. I'm here for you. So thank you, everybody.